Having looked at hypovolemic hyponatremia, let's quickly look at euvolemic hyponatremia and probably hypervolemic hyponatremia. So we'll begin with euvolemic hyponatremia. Now, when you say euvolemic means that the volume may be higher or lower, but there's no abnormal increase in the extracellular fluid volume. So when you say euvolemic, the volume can be higher, a little bit higher, or a little bit lower, but there is no significant change in the extracellular fluid volume. So that means that the fluid volume can be high, but ECF volume will still remain within normal limits, right? Now, in this situation, what it means is that the sodium concentration, because you remember that we measure sodium against fluid volume. So your measurement is, that's why you have millimoles per liter. You are measuring per volume. So anything that changes the volume of fluid in which you are measuring sodium, that can affect the sodium volume that you eventually will get. So now, in this situation, we are talking about euvolemic hyponatremia. Now, euvolemic hyponatremia is most commonly caused by a condition known as inappropriate antidiuretic hormone secretion, SIADH. Inappropriate antidiuretic hormone secretion. That's the most common cause of euvolemic hyponatremia. Now, what this means is that if antidiuretic hormone is secreted in excess, it will cause an increase in volume or water retention. That means water will be reabsorbed from the kidney more than is necessary. But remember that this volume water reabsorption that is occurring is expanding the extracellular fluid volume. But then the extracellular fluid volume is not higher than normal, even though it is expanding it. That is why it is called euvolemic. So this syndrome of inappropriate ADH secretion facilitating the increase in extracellular fluid volume as a result of water retention from the kidney, it will cause that increase or that expansion of ECF volume will cause a dilutional effect on the sodium concentration in the individual's body. Remember that fluid volume is increasing, is expanding, but sodium concentration is not increasing. So when you take sample from that individual at that point, you measure sodium concentration, you realize that sodium will be low, right? Sodium will be low. So the most common cause of euvolemic hyponatremia is the syndrome of inappropriate antidiuretic hormone secretion. So this is the most common cause, and that's why you have euvolemic hyponatremia. There's a dilution as a result of the accumulation of the water, as the ADH is facilitating the retention of fluid. It is diluting sodium concentration. So when you measure sodium in that situation, because you measure sodium against volume, sodium concentration will be low. So next we discuss hypervolemic hyponatremia. Hypervolemic hyponatremia. Hypervolemic hyponatremia occurs when the ECF sodium is normal or maybe slightly elevated, but the extracellular fluid volume is increased. Extracellular fluid volume is increased higher than normal. Remember, in euvolemic, ECF is still within normal, but in hypervolemic hyponatremia, ECF volume expands. There's an abnormal increase in the volume of the extracellular fluid. And so because of this extracellular fluid expansion, that expansion will cause a dilutional effect on sodium concentration. And when this happens, when you measure sodium in this situation, sodium will become low. And so that's why you have hypervolemic hyponatremia. Now, there are two major causes of this hypervolemic hyponatremia, and this is congestive heart failure as well as um, cirrhosis, um, congestive heart failure and cirrhosis. Then it can also be caused by nephrosis. That means the end stage of renal disease, the renal damage. So we said congestive heart failure and end stage of renal disease. Now, when you say congestive, how does congestive heart failure now cause hypervolemia? You remember that the heart is responsible for the pumping of body fluid, particularly the blood, to circulate around the body. Now, if there is a reduction in the activity of the heart, maybe there's a failure in the activity of the heart, that reduces the ability of the heart to effectively pump blood to circulate. And if the heart is not able to effectively pump blood to circulate, there will be fluid retention in the body. The fluid cannot be pumped to go around the circulation to go and get to the kidney, where the kidney will be able to filter fluid out of the body. So somebody can be drinking water, but because the heart is not able to pump the blood effectively around the body, the fluid will be retained. And when the fluid is retained, it will result in the expansion of the extracellular fluid compartment. And so when the ECF compartment is expanded, that expansion will now cause a dilution in the sodium concentration. And so when sodium concentration is diluted, because as a result of that expansion, when you measure sodium in that situation, remember that we always measure sodium concentration against volume. When you measure sodium, sodium becomes low per volume. Remember that we report sodium per millimoles per liter. So in that situation, that expansion will result in a reduction in sodium concentration because the water accumulation has caused a dilutional effect on the sodium concentration. That is for that. Now, another thing too that we said can cause a retention of fluid is the kidney. The heart may be functioning very well and pumping fluid very well to the kidney. And but the kidney, because of renal disease, renal damage, there's a damage probably to the glomerulus, and so the glomerulus is not now able to filter fluid out, right? Anything that damages the cells of the glomerulus, it will affect the ability to filter fluid out of the body. And so when fluid cannot be filtered out of the body, what happens? It results in accumulation of these fluids, and this accumulation of fluid will cause a dilutional effect in sodium concentration. So when you measure sodium in that situation where there's an expansion in the extracellular fluid compartment as a result of the inability of the kidney to filter water out of the body, the sodium concentration will be low to cause hypervolemic hyponatremia. Volume is expanded, but sodium is low. So that's it for hypervolemic hyponatremia. Hypervolemic hyponatremia.